Hi everyone, we are adding another methodology to our machine learning batch. Today, we continue with three methods which are mostly used in computer science. We will focus on decision trees, which is a supervised learning model. So far, we have covered k-nearest neighbors method and logistic regression model as supervised learning methods. We learned their theory and saw how they work in practice. You can check those videos with the link above. Let us start with today's topic. Decision trees are supervised learning algorithms we need both the feature matrix X and a vector Y showing the labels. They are used for both classification tasks and also regression tasks. We will mention how to make predictions for each type of task in a minute. The method segments the predictor space into regions using splitting rules. At the end of this segmentation, you obtain many regions, and you will use these regions to make predictions. For instance, if it is a classification task, when you are given an observation, you first find the related region that the test observation falls in. Then, you can use the mode response value of the training observations in the related region. For the regression tasks, again, you will find the related region, then you can take the mean value of the training observations in that region. We will show a small example in the next slides. Let us have a look at a basic example in practice. Assume that our data has two features, x1 and x2, and also assume that the space of these two features is shown as the rectangle. Before moving forward, let's say we have these training data points. Remember that the model aims to find the subregions over the whole space. How does the method do this? Well, in the following way. The method looks at the observations and creates what we call splitting rules. As you can see such a rule on the screen, which is shown as a red dashed line. As you expect, this rule divides the space into two regions, R1 and R2. The method continues until a certain condition is met. So far, we have seen what decision trees are and how they are working in a broader sense. Let us now focus a bit on terminology of decision trees. As a starting point, unlike the real world, trees are generally drawn upside down, so that the leaves stand at the bottom. We call the regions R1, R2, and R3 as terminal nodes or leaves nodes or leaves. We call a node an internal node when it is not a terminal node. Now we can move on to the tree building phase. In general speaking, there are two steps of building a tree. First, we use the training data for dividing the predictor space into J distinct and non-overlapping regions. Then we use those regions for predicting the test observations. Step 2 is an easy thing to do. However, things are not really clear for step 1. We don't know how to divide the predictor space. Let us focus on step 1. As you remember, for now, we are doing a regression task. Thus, our goal is to obtain the regions that minimize the residual sum of squares, that is, the summation over regions and observations in the related regions yi minus yi hat rj square. Note that yi values are the true values of the observations. Since we are doing a supervised learning task, the true yi values are available. Also, y hat values are the predicted values over the region rj. The next question is that, how are we going to find the regions that minimize the RSS value? What we will do is that we will pick a feature xj and a splitting point s. As you may guess, there are many possibilities for j and s values. We will pick the ones which decrease the RSS value the most. Mathematically speaking, we are looking for the j and s values that minimize the summation. This is a division operation. We need to repeat this process iteratively so that we further minimize the RSS value. This process continues until a stopping criterion is reached. For example, we may continue until no region contains more than 5 observations. Now, we will focus on building a classification tree. A classification tree is very similar to a regression tree. However, the difference is that classification trees are used for predicting a qualitative response rather than a quantitative one. Remember that a regression tree predicts a response for a test observation by taking the mean response of the training observations in the same terminal node. In contrast, a classification tree predicts the observation as the most occurring class of training observations in the region to which it belongs. The way to grow a classification tree is the same. We will split the whole space into regions, and we do this recursively. However, this time we cannot use residual sum of squares. Alternatively, we can use the classification error rate, which is given as 1 minus maximum of p hat mk over case. Here, p hat mk is the proportion of training observations in the mth region that are from the kth class. For classification trees, there are multiple error measures. Actually, we could only use the classification error formula as an error measure. However, it turns out that classification error is not sufficiently sensitive for growing a tree. In practice, 2 other measures are preferable, which are called Gini index and entropy. The Gini index is defined as summation over k classes p hat mk times 1 minus p hat mk. As the p hat mk value decreases, the Gini index value approaches to 0. This is also why Gini index is sometimes called a measure of purity. The last alternative error measure is the entropy, which is given by, again, the summation over all k classes p hat mk times log p hat mk. As in the Gini index, entropy takes a small value if the mth node is pure. Actually, it turns out that the Gini index and the entropy are quite similar numerically. After selecting the error measure, the procedure is the same. We are going to find the regions that minimize the error value by picking a feature xj and a splitting point s. We continue to repeat this process iteratively so that we further minimize the error value. Until a stopping criterion is reached, we continue to divide the space. So far, we have learned the basics of decision trees. There are, of course, advantages and disadvantages of this method. On the advantage side, trees are generally easy to explain to people, even easier than linear regression since it is similar to human way of thinking. They are quite interpretable since they can be displayed graphically, so that even non-expert people can see the reasoning behind the predictions. Trees can easily handle qualitative predictors without the need to create dummy variables. On the disadvantage side, trees are non-robust models. This is because a small change in the dataset can cause a large change in the tree structure, which directly affects the predictions. Another thing is that decision trees can overfit the data very easily. However, there is a way for preventing this overfitting problem, which is a tree pruning process. We will not go into details about tree pruning process now, but you should be careful when you're using decision trees. Today, we have covered decision trees, regression, and classification trees. We saw the way of making splitting operations. We also discussed the different error measures for classification trees. Lastly, we briefly discussed the pros and cons of the method. We are looking forward to your feedback or questions. Thank you for watching our videos. Please do not forget to hit the subscribe button. By doing so, you are really helping us to grow. You can always ask questions by leaving a comment below, and we will be happy to answer it. Our next video will cover another fundamental algorithm in supervised learning method, random forest. See you in the next videos. Bye bye.